Okay, laws of indices then. So an index is something that is the power of something else, and there are 7 kind of base rules which you need to know for the A-level specification. It was on the GCSE specification as well, so you should all be familiar with these. But just to recap, as these are kind of fundamental to a lot of the algebra done at A-level. So 3 of the rules I learned as acronyms: TIP, PIT, and DIM. You may or may not have heard of these. It doesn't matter whether you remember TIP, PIT, and DIM or not. It's the rules themselves that you need to know. So TIP is times indices plus. So if we have x to the a times x to the b, okay, so we're timesing 2 indices together, then we plus the powers, or we add the powers. So that's x to the a plus b. Okay, if there's ax's in here and there's bx's in here, then there's a plus bx's all together, and they are all just times together. Okay, PIT is power indices times. So this is x to the a to the power b. So I'm going to power an index, or raising an index to another indice. And PIT says I times the powers together. So this becomes x to the a times b. And finally, DIM, similar to PIT, DIM is divide indices minus, so I get x to the a divided by x to the b, which may be written as x to the a over x to the b. They are exactly the same thing. Then we minus the powers, so it's x to the a minus b. Okay, so those are the 3 acronyms that I've learnt. There are 4 other rules which you need to know that concern indices. So x to the power 0 is always equal to 1. Now there is a little side note to this. That's x not equal to 0, just to be strictly true. But any other number, real or complex even, if you raise it to the power 0, it is the number 1. Any number raised to the power 1 is itself. Okay, so these are 2 very straightforward rules, which hopefully are very intuitive for you. Next one is a negative indices, so x to the minus a. This is sometimes called reciprocal, because it's equal to 1 over x to the positive a. So if we have a negative exponent, a negative sign in the power, then we can remove the negative and put it 1 over instead. And the other one is a fractional, so 1 over n as the exponent. That is equal to the nth root of x. So, for example, if n was 2, then it would be the square root. X to the half is the square root of x, or x to the third is the cube root of x, and so on. Okay, so those are the 7 kind of base rules here. We've got tip, PIT, and dim, a 0 power, a unit power, a negative power, and a fractional power. And we can combine 2 of those just in case we have something like x to the a over b, where a isn't 1, so we cannot just apply this. Well, we can apply PIT backwards, so that will give us x to the 1 over b to the a, and if I were to apply PIT to this, I'd get back to this. So I'm reversing PIT, and then I can see, well, this is the bth root of x to the power a. Or we could say, if you did it the other way around, it's x to the power a, and then the bth root of that. These 2 are the same number. Okay. All right, so that's all the algebraic rules that you need to be aware of for A-level maths. A couple of examples then. First one involving some numbers. So all of these rules here, they are all algebraic, and yes, we do apply them a lot to algebraic expressions, but students tend to forget that actually they apply to numbers too. As long as the base is the same, in this case base was x, as long as the base is the same, these rules apply. So let's say we were given this question here and we wanted to write that as a single power of 5. So what is the value of k in this case? Well, we can say that 25 is actually just 5 squared. Root 5, well, that's just 5 to the half. using the fractional power. That's going to be raised to the power 2. And then that's all going to be divided by 125, which I can write as 5 cubed. Okay. Inside this bracket, we're going to apply tip. So we're timesing two indices together, so we're going to add the powers. So we get 2 plus a half is to the 2.5, and that is still squared. And I've not done anything to the bottom, so that's still 5 cubed. That is equal to, you apply pit here, so that's going to be 5 to the 5, because we can times these two indices together, so 2.5 times 2 is 5. Still not done anything to the bottom, so it's still 5 cubed. And now I can apply dim, divide indices minus, so I'm dividing two indices, they've got the same base, so I can minus the powers, so that becomes 5 to the power of 5 minus 3, which is 2. So k in this case is 2, and this thing up here is equal to the number 25, okay, which is 5 squared. Another example, a more algebraic one. We've got a squared times b, all cubed, divided by a to the 5 times b to the 4. So when we are applying an exponent to two things in a bracket, then the exponent applies to both of those. It's actually going to be a to the 6 times b cubed, remembering that b is the same as b to the 1. And then we can apply pit to both of those to get a to the 6 b cubed. And that's divided by a to the 5 b to the 4. And now we can apply dim for both a and b. Don't forget that these laws of indices apply if the bases are the same. In this case, we have base a, so it's going to be a to the 1, and base b is going to be b to the minus 1. So we can write that as ab to the minus 1, or you could leave that as a on b. That is also fine. Either of those two is fine. Best not leave it like that, because we don't usually write an index of 1. Okay. One further example I just want to touch on. If I have something like 2a squared all cubed, just like up here, we applied this cube to the a squared and the b, we must apply this cube to the 2 and the a squared. So that's going to become 2 cubed, which is 8, times a to the 6, which is where the 6 comes from the 2 times 3. Okay. A lot of students will incorrectly write that as 2a to the 6, which is wrong. This is right. Okay. Thank you for watching.